Okay, so today's lesson is looking at inverse normal probability. So in the last few lessons, or last couple of weeks, what we've been doing is looking at using normal distribution, from real life x values, converting them to z values, and then working out the probability of those things happening. Inverse normal is really simple, as it's working the other way. So if we know the probability, can we convert that to a z value to then work out an x value? So what that requires is a little bit of rejigging. Here's firstly an inverse normal question. Natalie cycles to her grandmother's house every day after school. The time for the journey is normally distributed, with a mean of 25 minutes and a standard deviation of 4 minutes. There is a 90% probability that she will arrive at her grandmother's house before 4 p.m. When does she leave? When does she leave school? So, what we need to think about is how is this question different from the normal distribution questions that we've been dealing with? First of all, there's a probability in it. That was our answer in the previous part. What we still have is a mean. We still have a standard deviation. So if we think about it, how can we represent this problem to work out what is it that we need to do? Well, if you remember the first step in when we were doing normal distribution, the first step was to draw a diagram. And now you'll know the reason why I've usually put up a picture there of a normal distribution curve. So the key thing is we put in the mean, which in this case is 25 minutes. So that means on average it takes you 25 minutes to get home. But there's a standard deviation of 4 minutes, meaning that it varies. So if we remember about the one standard deviation, that is 68%. So 68% of the time, she'll take 21 to 29 minutes. Okay. But the bit we don't know is that she knows that there will be 90% of the time there will be that she'll get to her grandmother's house before 4 p.m. which is represented by that area there. So what we need to know is, first of all, we need to know what Z value is 90%. There's 90% of values below, and then convert that to which X values, where it's 90% below. Now, if we know the number of minutes, then we'll know how long before 4 o'clock she has to leave. So, how do we structure it to answer the questions? Is that we have to change the setup of how we answer the questions. So first thing, draw a picture. The next thing, look up the Z scores in a table. So that's slightly different from what we've seen before. Number 3, we calculate the X value from the score, and that's required a rearrangement of our previous equation. So if we remember back, the previous equation was X, take away the mean, divided by the standard deviation gives us the Z value. This way around, we're going to find the Z value, and then we're going to convert it back. And then lastly, write the value in context. So if we take our question again, and we go through the steps, first thing we do is draw a picture. So there's our picture. Step 2, so we need to look up the Z score in the table. Now, this first thing we should think about is that in the previous lessons we have been looking at the outside. because it's inverse and we're going the other way, we've got the probability, we've got to work back. Now, the first thing you should notice is when you're looking at the table, through the whole table, I've just cut a section of it out, is that we should notice that 0.9 or 90% is not there. And that's because we measure it from the mean. So what you have to remember with this question is that 0.5 is represented here in this left half of the chart. What's on the right hand side, I'll just change colours to highlight that, the purple part is actually the area we need to work out, and that's actually 0.4, because the 0.5 and the 0.4 together make the 90%. So again, that's another one of those things you need to think about. So now that we've got 0.4, that's our probability. So we look on the table for 0.4, and you can see the closest we've got to 0.4 is here. Now, you might see that the one next to it is 0.4015. We're not going to use that one because it's too big. It's always better to go the first one under a value, because what we can do is add a third decimal point. So if we look where that is in the table, it's 1.2, 1.28. So that means that Z must be equal to 1.28, and it's 3 less. So I'm going to try and add 2 more by putting a third decimal point in there. So the closest we can get is 0.3999, which is 1.281. Now I could make it 0.282, but that would end up, we would end up with 0.4001, and that would be too large. So because the tables only go to 3 decimal places, it's only as accurate. Sometimes it's not as accurate as it could be. So now that we've got our Z value, we can look to do steps 3 and 4. What I'm going to do though is pause that here, because I think that's an important skill to be able to do, is find the correct Z value from the table. So I've got a separate exercise here where I've got a table. What I want you to do is have a go at finding the Z scores for the following probabilities. Can you find the first decimal place, second decimal place, and in some cases the third decimal place for each of those questions? Pause the video now and give that a go. Okay, hopefully you gave that a go. Let's take a look. So A is looking at 0.1700. So you'll notice the table as you're going through, it goes up in order. So you can see the probabilities are getting bigger and bigger as the standard deviations are getting bigger. And then you'll notice we find 0.1700. So from there, we get 0.4 and 4. So the Z value for a probability of 0.1700 is 0.44. Okay. If you didn't manage to get that first time, you can always pause the video and try and do the others now. Otherwise, we'll carry on with the answers. Okay, so B, we're looking at 0.3413. So 0.3, it's going to be further on here, 0.34. 3413, there it is, and it's 1.00. Okay, so hopefully you got that. Again, you can always pause and do the next one. So for C, we're looking at 0.1107. So 0.1107. Now you'll notice as I'm going through this, we've got 0.1103 or we've got 0.1141. So that's the closest one, or the one that's just under it. So when you're between two numbers, go for the one that's less. So that means that our Z value must be equal to 0.28. Now, can we make that 0.07? All right, and then yes, we can by just adding 4 on the end there. So 4 on the end there means that we get another 1 on top of that. Have a go at D if you haven't done already. So D is 0.2779. So 277.779. So that one's too big. So it's not that one. So it must be this one. And we've got 0.76. And the third decimal place, can we make it with a third decimal place? So we're 15 short. So is 15 in here? Yes, it is. And then we can find the 5 there. So we need to add a 5. So they are our Z scores, which is ready for that third step of the calculation. So before we move any further, there's an exercise in your workbook and on the lesson page of the OneNote, which you can have a go at. Go back through this video if you need to, of finding Z scores or from the probabilities.